A very warm welcome to everyone watching this video over the YouTube. Myself Rahul Misra from BPUT University of Technology Odisha, Rourkela, and here I welcome you to my video, and we shall have a brief introduction and a brief welcome to the machine learning techniques using a simple case-based project. Now, as you can see that the best way to learn something is to learn while doing. Therefore, we shall be invoking ourselves to a problem statement, and this is the problem statement which you can see in front of you, and all we will be doing is to solve this problem statement using the ML tools. As we can see that we are given with a CSV file, and this is actually not the CSV file, this is the pandas dataset, and this dataset contains the data regarding the flats. The 0, 1, 2, 3, 4 are the flats, and the various features, the exact term which we use are the price, the area, the address, the bedroom, etc. For example, here we have the flat number 2. The flat number 2 has the price 3, I can count the number of zeros, and the area of the flat in the square units, and the location where this flat is located, the bedrooms, and so on. Now, all we will do is to make a machine learning model which shall account the various factors. That is, for example, if you want to buy a house, or if you want to keep an rent of a flat in Bangalore, please specify the address, please specify the BHK and the other factors, and our model shall very politely give you the price of the flat. You can say that this machine learning model is quite a simple one. Okay, you are going to account all these features and you are going to predict the value of price. Means you are simply solving a equation y is equal to mx plus c. But dear friends, this is the very driving engine of all the real estate query apps that you can see in the Google Play Store. So without wasting any kind of time, let us dive into this simple but very applicative problem. Before moving further, let us formalize some definitions about ML. Although everyone of us watching this video knows what is ML, but still better to formalize that this entire slide, what this slide is telling, I can summarize that ML is simply using statistical tools and algorithms in order to make decisions. The very algorithm or technique which makes decision fitted inside a computer program is called model. The very act of decision making is called prediction. And here we have defined the learn recursively, that if we supply more and more data to the model, the accuracy of the prediction increases in many folds. If that accuracy increases, then we can say that the model is learning from the data. And the process of supply of data into the model is called training the model, and the process of checking whether our model actually does something or not is called as validating the model. Now let us move into our model, but before that, let us have some comparison between statistics and machine learning. As you can see around yourself, I can put a simple joke to describe everything, that a data analyst is simply the person who knows more programming than a statistics person, and more statistics than a software engineer. Now, the first code of our problem. Here we have imported our tools. This is the NumPy. This is the Seaborn. For somebody who doesn't know what is NumPy and Seaborn, these are simple but very applicative tools that are used to visualize the data. And this is the pandas, and the very driving engine of the machine learning algorithm and machine learning code in our problem statement will be the scikit-learn tool. and this entire stuff is the Python stack. As you can see, the very language for machine learning. And the GeoPy which is present over here, it shall be used for a feature engineering, and we shall be learning what is the exact feature engineering that has to be used for this data. And the data is all about the Bangalore city, and let us welcome to Bangalore. Now this is the very first line. We have imported the CSV file, a very dull and rudimentary file, into our pandas dataset, and the pandas dataset is simply the pandas data frame. The data frame is simply a very hot and sexy table which you can see in front of yourself. Now this table, as you can see, contains 6207 rows and 40 columns after the dropna has been done. And what is dropna? Dropna means drop not available values. This is done as a process of cleaning the data, because see, there are many machine learning tools that are not immune to non-data. For example, the very decision tree regression that we shall be using here, it cannot simply accept the null values. We have to do a lot of things for that. So the very first process which we can do is to clean the data and to clean the null values. So here we have used the dropna. Now the 40 features that you saw in the previous slide, this is the list of those 40 features: the price, area, address, bedroom, etc. And I want to simply describe a single feature, that is what are the different values in that single feature, here we have the scatter plot. The scatter plot contains the area and the price, and here this is a plot between the area and the price that is implemented in the pie plot and the seaborn. Now the plotting is not a big deal, but analysis is a big deal. The very simple questions that one must ask, that does every feature matter in our machine learning model? Those feature like sofa, refrigerator, etc., does that exactly affect our model in the way price, area, address affect? The second question is that does every value in a particular feature, for example this area versus price feature which we can see, there are some values in the extremity. In the technical jargon, we can call them as outliners. So does these outliners affect the data? And how can we uh, process our data for effective implementation of the model? Now the very question that does every feature matters, it's about your technical knowledge in that domain. Therefore when we ask about what are the three steps that are required for machine learning, I would say that for machine learning you should have a proper command of the mathematics. The second is coding and programming, and the entire machine learning algorithms which we have, and the very third but the most important uh, problem and the most important factor is to consider all the features. You must be technically sound in the domain to cancel out some features that are not important in the uh, machine learning model. Therefore I don't want to repeat that thing. Let us move to the outliners problem. Now this is the exact outliner problem. We can understand it simply as the uh, we can see the graph here. If we account for the outliner, then the median lies something here. But if we remove those outliners, here I have marked red, then the median moves to a better position in the data. For someone who is not able to understand this, I can simply give you an example that in a class particularly, if the strength of the class is 50, 30 students have barely passed a paper, and 10 students they have okay okay is kind of performed, and there is one student who has scored the outstanding grade. If we account that outstanding student into the data, then the very mean shall move or shall shift towards that outstanding boy, because the amount of mark he has secured is definitely way more than the rest of the class. But the exact average or the exact mean that we shall be getting is when we remove these outliners. The black outliners that are towards the end of the graph have to be removed, and after that we can exactly place our uh, median or mean. As you can see, perhaps there's a simple mistake. This outliner should be very high, but I have given it very low. Please correct that. But anyways, now what is feature engineering? See, in our model, let me go to the huh, yes, in our model, the location, this location is simply a string means a character. Okay, the machine learning model or the regression model, that will face a good deal of issue when it process itself on these string values. Therefore we have to think a way so that we can convert these strings into numerical data. Now for this again domain knowledge is required. The string, what does that exactly represent? The string represent address. Now address means you are locating something in the globe. For the very act of locating something in the globe, we use longitudes and latitudes. Exactly. And everybody of us know that the longitude and the latitude are numerical data. So here, what exactly we are doing? Yes, we are introducing some features into the data or some columns into the data that were earlier absent, but there those columns and those features are needed for the very purpose of modeling our data. Therefore, this is the feature engineering which we have done. And for the process of appending those longitude and latitude into our data set, we have used a very helpful Python module and library and tool, that is geocode. And this is the code of the feature engineering which we are seeing. And after every value in the data set has been geocoded, we are updating the CSV file. If you are not able to understand exactly what is written in the code, no problem, revisit this code a lot of times. You can comment me for your doubts in the comment section below. Now let us move to the model. For the 13 minutes in this video, I have just described how to process the data, but in actuality also the machine learning process is simple process, because the machine learning is a single code, but the very act of processing the data for machine learning is a difficult and tiresome task. Now here we have our example. Now just remember that I'm not taking the exact features or the exact data set. I'm taking a very simple example because our data set contains 40 features, but we cannot exactly visualize those 40 features into our real earth, because we cannot even visualize more than 3 dimensions in the real world, forget about 40 dimensions. So let us uh, move to a more simpler example. Later we shall correlate our example with the dataset provided above. So now here I have some color dots or some pixels. The value of the pixel lies from -123 to 225 as regular, and those pixels have some specified location in the Cartesian plane. If you want to correlate at this instant that how this problem and our original problem are related, we can see that uh, yes, this price, these are analogous to the pixel, and the entire range of features, they are analogous to the location of the pixel in the coordinate plane. I hope you are now able to understand what I am talking about. Now, the model which we shall be using shall be the Decision Tree Regressor, a very famous tool in the scikit-learn, and here we have the problem. Now, these are the various pixel points in the Cartesian plane, and for solving this problem, what I need to do is to somehow tell that an unknown pixel of a given pixel value between -123 to 225, when it is to be found inside this given Cartesian plane, or whether it has to be decided that where this particular pixel value will be best fit inside this Cartesian plane, we have to somehow divide this Cartesian plane into locations where a given amount of pixel value is present. That is what we are doing. See, here these are the range of pixel values, if you can see the mouse in the top. Now we have to divide the entire Cartesian plane containing the pixel values into clusters. See, this is a regression problem, but the very act here is clustering. We are clustering those pixel points. We are grouping those pixel points into locations. Now, the x value is simply the, we can understand as the location value somehow, and we are using our tree, we are using the tree structure in order to divide the pixel values into clusters. Now for example, here we have the entire range of pixel. As we can see, we want to put a single line that divides the more redder ones and the more yellower ones. Therefore the redder ones goes to the right, the more yellow ones goes to the left. Again, in the yellow ones we want to sort out the orange ones and the more yellow ones. Therefore we divide, or technically I can say we split this given data sets into two trees, right and left tree. So after this splitting that has been done, we can divide the entire Cartesian plane into something beautiful like this. Yes. So the entire Cartesian plane has been clustered into different data zones. For example, I want a red dot. I shall place it somewhere here. And this is the location for the red data. So all I shall be doing is simply traversing this tree and finding the best possible place for the red data. Traversing the tree simply means moving from the top to the most accurate cluster for the data. For example, I have a red data. From the top, I shall be going to the more redder ones. Then from the redder ones, again to the appropriate red. See, I have two reds over here. The girls may better understand the colors because boys have kind of less aptitude for colors. And again, after this, we got to place our this red dot into the appropriate cluster. Now the exact location of this red dot and the exact value of this red dot shall be the average of the value of these three red dots. Now this is the process of prediction, but the very act of splitting is also a very kind of difficult act, because how we have to choose the splits. This is the color range set that we have. How we can choose the color range sets so that the redder ones shall go to the right, sorry, the redder ones shall go to the left, and the more yellow ones shall go to the right. So we can understand that this redder ones, sorry, this entire color range, that has to be splitted into two values. The split should be in such a way that the amount of variance is decreased. For example, here the colors vary in huge ranges. Here we have some red, some pink, some yellow, like those things. So we want to divide the color into two clusters so that two clusters each shall have less variance. For that, in this cluster, you can see in the left, it has only kind of yellow and orange. It does not have any kind of red anomaly. Similarly, in the right, it has only red. It does not has any kind of yellow anonymous data. Therefore, we are decreasing the amount of variation in the data with each split that we take in the depth of the graph. Therefore, how to account the variance? We account the variance using the simple tool that we learned in class 11th, that is the variance. The data sets which you can see here, the variance is calculated, and the variance of the two splits are calculated, and we see that has the variance decreased or has the variance remained same or has the variance increased. Now if you ask me what exactly the model does, the model simply checks the amount of variance for each and every split that can occur. That is what the exact linear tree regressor, sorry, decision tree regressor does. And this is the very engine of the decision tree regressor that you can see. Now let us move to our code. Now here we have imported our decision tree regressor, and for validation we have used the mean absolute error. The mean absolute error, uh, that's nothing but the exactly variance checking of the prediction and the data. So here it is the code, and you can see, as we are running out of time, I want to describe this code in a very simple short, that after we have imported all our models, we shall be dividing the entire data sets into two data sets. One data set is for training and one data set is for testing. Testing means validating the model. So this is done by the test split. So this is done because actually we are supplied with a single data set. The process of training and the process of validating shall take place from the datasets given. Therefore, we have to split the dataset, and here we have split at this. And after splitting the dataset, we shall be using our we shall be using our decision tree regressor and the model imported into the function decision tree regressor m. And the process of fitting is done. The fitting process is nothing but the process of learning. If I could have time, I could have made a very beautiful tree that describes the process of prediction, but the structure of the tree is nearly same as this tree which you are seeing in front of yourself. And after fitting the model, or after making a generalization, we are making our predictions based upon the test data, and the test data is our x. I should tell you that this x is simply the price data, and the y is simply the features that we say that x is the independent variable and y is the dependent variable. Sorry, I just made a mistake. The y is the dependent variable, that is the price, and the x are the independent variable, that is all the list of features. So here the fitting between the x and y is done, that is the regression exactly in a decision tree manner is done, and the prediction is done here. And we have checked our mean absolute error, and it's coming to be 21 nearly. And since the error is coming to be 21, we can somehow say that it's an average model. But the process of decreasing this MAE, or mean absolute error, is the process of increasing the efficiency of our data learning model. Now we have a better method of data learning model, or a better method of ML, that is random forest regressor. And what random forest regressor does, it simply makes out a number of decision trees, and the net result is taken by the average value of the results obtained from the decision tree regression. So this much is the model. Here are the references, the entire visualization, the normalized nerd. Thanks Blue for helping me a lot, and you can refer to him for better visualization of this entire decision regression tree method. And the exact code is referred from Manoj and Suruchi in the Kaggle. Excellent code they have made for us. And at the end, this is the very beautiful philosophy of this entire ML. See, because from this video we can even see that the very process of thinking has to be done by the human being. The machine learning is there to give us interpretation, but the interpretation has to be done by the human being. And thank you, thanks a lot for carefully listening me and having the patience. Please like, share this video, and your support shall be a motivating factor for me to bring out more and more uh, tutorials and more resources for every one of us. And I know that the very machine learning model, that code, I have not justified it properly, but see that that is the very fundamental thing that is happening here. And if you request, then I shall be making a more video that describes the entire working of the code. For that you have to pay your likes and comments for that, and please put your valuable comments. And my dear friends, this is my first YouTube video, so I apologize with my full heart for the language and for the presentation. And so this much, thank you, have a nice day, and all the very best for your future. Thank you.